Hello, my name is Yunus and today I will talk about quadrilaterals under polygons. Before starting anything, I want to talk about the history of polygons. Polygons have been known since ancient times. The regular polygons were known to the ancient Greeks with the pentagram, a non-convex regular polygon, a star polygon, appearing as early as the 7th century before Christ. And this is the picture of the pentagram. The first known systematic study of non-convex polygon in general was made by Thomas Bradbury in the 14th century. In 1952, Geoffrey Colin Shepherd generalized the idea of polygons to the complex plane, where each real dimension is accompanied by an imaginary one to create complex polygons. This is the picture of the Thomas Bradbury and this is the picture of Geoffrey Colin Shepherd. So let's start with the exciting stuff, quadrilaterals. Before starting with the quadrilaterals, I want to briefly explain the history of the quadrilaterals. Quadrilaterals were actually first discovered by the ancient Greeks, but when they invented it, the quadrilateral only had 3 sides instead of 4. It is said that Pythagoras was the first to draw one. It was the genius of the Romans to add a 4th side, and they were first to make a list of different kinds of quadrilaterals. But it wasn't until 1813 that an English mathematician, J.P. Smith, discovered the trapezoid. Did you know that mathematicians are still trying to find the general formula for the number of interior angles? This is an interesting fact I found on the internet while searching about this topic. If you want, you can try this at home. Many people find learning about quadrilaterals useless. They are actually wrong. Quadrilaterals are used quite often and you may not even know it. In ancient times, quadrilaterals were used for art, design, and architecture, which means that everyday jobs still needs to use quadrilaterals. These are some examples I found on the internet. A rectangle cut diagonally makes equal triangles, and the idea of congruency in the triangles was used by the Egyptians to make the Great Pyramids of Giza. The congruency of triangles formed by rectangles even helped Leonardo da Vinci to draw his famous painting Mona Lisa. So, what is a quadrilateral? A quadrilateral is a shape which has 4 sides, meaning that any shape with 4 sides is a quadrilateral. A square, a rectangle, a rhombus, a kite, a parallelogram, and trapezoid. A quadrilateral may be convex or concave. A quadrilateral that is concave has an angle exceeding 180 degrees. A convex polygon is defined as a polygon with all its interior angles less than 180 degrees. This means that all the vertices of the polygon will point outwards, away from the interior of the shape. Properties of parallelogram. As you can see in the picture, opposite sides are parallel, diagonals bisect each other. In parallelogram, 2 consecutive angle bisectors intersect on the median of the parallelogram at the right angle. Diagonals divide the whole area into 4 equal. As you can see, 4 congruent areas. K and L are the midpoints of DC and CB, respectively. Area of ALCK is equal to the half of the area of the parallelogram. Area of a rectangle. To find the area of a rectangle, just multiply the length times the width. Properties of a square. A square has equal sides and every angle is right angle. Opposite sides are parallel. A square also fits the definition of a rectangle. All the angles are 90 degrees and the rhombus, all sides are equal length. It has all the properties of a rectangle, therefore of a parallelogram. The diagonals intersect at right angle, as you can see here. Perimeter of a square. Add up all the sides of a square, like 4x, if we call it side x. To find the area of a square, multiply the length of 2 sides together. If we call it side x, it's x squared. Properties of a rhombus. All sides of a rhombus are congruent. Diagonals are perpendicular. The diagonals bisect the vertex of a rhombus. Perimeter of a rhombus. To find the perimeter of a rhombus, just add up all the lengths of the sides. Area for rhombus. To find the area for rhombus, multiply the length of the two diagonals and divide by 2. Another way to find the area for rhombus, just to multiply the height with the base of the rhombus. To find the perimeter of a parallelogram, just add up all the lengths of the sides. Perimeter equals a plus b plus a plus b. Area of a parallelogram. To find the area of a parallelogram, just multiply the base length times the height. One more way to find the area of a parallelogram is to multiply two non-congruent sides and then multiply it with the sinus of the angle between two sides and the sinus of the angle between. Properties of a rectangle. A rectangle is a four-sided shape where every angle is right angle, 90 degrees. Also, opposite sides are parallel and of the equal length. It has all properties of a parallelogram. The diagonals are congruent. If P is any point in the interior or exterior region of the rectangle ABCD, PA square plus PC square equals PD square plus PB square. Perimeter of a rectangle. To find the perimeter of a rectangle, just add up all the sides, all the length of the sides. Properties of a trapezoid. Trapezoid is a quadrilateral with only one pair of opposite sides are parallel. Parallel sides are called base and non-parallel sides are called legs. Leg angles are supplementary. If the legs of a trapezoid are equal, it's called an isosceles. Properties of an isosceles trapezoid. The legs are congruent, base angles are congruent, diagonals are congruent. Properties of a right trapezoid. Right trapezoid is a trapezoid with two of its angles 90 degrees. These are some examples of different kinds of trapezoids. This is an isosceles trapezoid, this is a normal trapezoid, and this is a right trapezoid. Perimeter of a trapezoid. To find the perimeter of a trapezoid, just add up all the lengths of the sides. Area of a trapezoid. To find the area of a trapezoid, multiply the base with the height of the trapezoid, then divide it by 2. Another way to calculate the area of a trapezoid is to add up the bases, multiply it by the height, and divide it by 2. And now my presentation is over. My friend Jean-Marc will continue with his presentation, and then afterwards we will start solving some questions.
Hello, my name is Jean-Marc. Now I will continue where Yunus left the presentation. Triangles. A triangle is a polygon with 3 edges and 3 vertices. It is on one of the basic shapes in geometry. Types of triangles. We can find types of triangles by relative lengths of sides and by internal angles. I will tell about the relative lengths of sides first. Triangles can be classified according to the relative lengths of their sides. An equilateral triangle has all sides the same length. An equilateral triangle is also a regular polygon with all angles measuring 60, at total 180. An isosceles triangle has two sides of equal in length. An isosceles triangle also has two angles of the same measure, namely the angles opposite to the two sides of the same length. This fact is the content of the isosceles triangle theorem, which was known by Euclid. Some mathematicians define an isosceles triangle to have exactly two equal sides, whereas others define an isosceles triangle as one with at least two equal sides. And the last one in this slide, a scalene triangle, has all sides difference, so all angles are unequal too. A right triangle is also a scalene triangle if the other two angle is not 45-45, so they should be different to be a scalene triangle. These are the types of triangle. This is equilateral, each angle is 60. Isosceles, two sides are equal length and these two angles are equal, and scalene triangle, all sides are different and all angles are. We can also determine type of triangle by internal angles. A right triangle is a triangle having a 90-degree angle in it, a right angle. The longest side of the triangle, which is the opposite side of the right angle, is called hypotenuse. The other two sides are called the legs. Right triangles obey the Pythagorean theorem. The sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse, which means C is the hypotenuse. A square plus B square equals to C square, where triangles that do not have an angle measuring 90 degrees are called oblique triangles. A triangle with all interior angles measuring less than 90 degrees is an acute triangle or acute angle triangle. A triangle with one interior angle measuring more than 90 degrees is an obtuse triangle or obtuse angle triangle. A triangle with an interior angle of 180 and collinear vertices is degenerate. A right degenerate triangle has collinear vertices, two of which are coincident. This is the right triangle. You see a 90-degree right angle, and this is the hypotenuse, and these are two legs. This is obtuse and acute triangles, which is the three of them is less than 90 degree, and so it is acute, and it's enough to have one angle is bigger than 90 degree to be obtuse, but these two are oblique. Basic in formulas of triangle. First, I will show you some basic formulas used for triangle, then I will solve more complex questions later. Interior angles of a triangle rule. This may be one of the most well-known mathematical rules. The sum of all three interior angles in a triangle is 180. As you can see from the picture below, if you add up all the angles in a triangle, the sum must equal 180. This property of a triangle's interior angles is simply a specific example of the general rule for any polygon's interior angles. As you can see, A plus B plus C always equals to 180. Relationship between sides and angles. The side in front of the biggest angle is the largest. Side in front of the smallest angle is the shortest. It's a very simple rule that will help you to understand triangle shape better. You can see from the shape, the largest angle is A angle, and the largest side is the one in the opposite of A angle. So, area of triangle. The area of a triangle is always half the product of the height and base. As you can see here, the base of triangle is here, and height of the triangle is drawn in red. So formula is here. You multiply base and height, and you divide it by 2. So which side is the base? Any side can be a base, but every base has only one height. The height is the line from the opposite vertex and perpendicular to the base. The illustration below shows how any leg of the triangle can be a base, and the height always extends from the vertex of the opposite side and it's perpendicular to the base. As you can see, every side can be a base, but all of them have different heights. The picture below shows you that the height can actually extend outside of the triangle. So technically, the height does not necessarily intersect with the base. So height can be outside of the triangle. So in some problems, you need to draw it by yourself. Maybe the easiest question you will ever meet. What's the area of this triangle pictured below? It's very simple. You just multiply the base with height and you divide it by 2, which is 15. We can find the area of triangle in two more different formulas. First one, Heron's formula. Heron's formula is named after Hero of Alexandria, a Greek engineer and mathematician in 1070 AD. You can use this formula to find the area of triangle using the 3 side lengths. Therefore, you do not have to rely on the formula for area that uses base and height. The picture below illustrates the general formula where S represents the semi-perimeter of the triangle. Semi-perimeter of the triangle equals to AB, 3 sides of triangle divided by 2. So you find the area in this formula. This is the second formula, side angle side. The side angle side formula for finding the area of a triangle is a way to use the sine trigonometric function to calculate the height of a triangle and use that value to find the area of the triangle. Area equals to 1 divided by 2a times b times sin x, and this is another formula. Pythagoras theorem. The picture below shows the formula for the Pythagoras theorem. In the pictures below, side C always the hypotenuse. Remember that this formula only applies to right triangles. These two are right triangles, so you can see the 90-degree angle, and the opposite side is always the hypotenuse. And these two legs, the square of these two legs equals to square of hypotenuse. It's always the same. We have 3 most popular terms in Pythagoras theorem. One is sine ratio. We can find it by opposite divided by hypotenuse. So if you will find the b sine b, you take the AC divided by AB, because AB the hypotenuse and AC the opposite of B. Cosine ratio, it's the adjacent divided by hypotenuse, which means CB divided by AB. And the last one, tangent ratio, it doesn't include hypotenuse here. It's opposite divided by adjacent, so in this case AC divided by CB. Now I will talk about geometric mean. This is a formula for right similar angles. As you can see here, it suggests that R divided by the height equals to height divided by the S. So it's all about similar triangles, like in similar triangles in a big triangle. Now you will understand better. So what does this have to do with right similar triangles? It turns out when you drop an altitude, the h in the picture below, from the right angle of a right triangle, the length of the altitude becomes a geometric mean. This occurs because you end up with similar triangles which have proportional sides, and the altitude is the long leg of one triangle. Here, long leg of the small triangle, and the short leg of the other similar triangle. So these two triangles are similar, and the solving of these questions is 3 divided by h equals to h divided by 9. Now let's get out of the triangles in maths and focus on how we use triangles in our life. There are probably thousands of examples, but I will show you a few of the most popular ones. In logos of many famous companies like Doritos, Adidas, Toblerone and cat. In some popular buildings and architecture, with our engineering improving itself, it's easier to make for humankind fantastic buildings, such as these ones. It includes all triangles, and maybe they use most of the theorems when building it. In some mysterious places and as the symbol of some associations. If you ask me, I will first remember Illuminati. It's an association which the most famous popular rock stars and singers in, like Rihanna or Beyonce, and the Bermuda Triangle, which is known as a cursed place which all planes and ships. Now we finished our presentations about the basics of the polygons. Now we will solve some more complex problems with Yunus. Let the questions begin.
Hello, we start with the questions. This is a question I found on the web. I like the question, so I will solve it. It's about squares. There's an angle 20.5 degrees, and there's a side 8 root 2. The question asks for the perimeter of the square. So we'll draw this line to make a triangle, and this angle becomes 22.52. Which make the triangle an isosceles triangle. So this side becomes 8 root 2. So and these angles become 45 degrees because diagonals divide the sides equally, and one side of a square is 90 degrees. 1 minute. When this side is 8 root 2, these sides become 8, and the perimeter of the square is 32. ABCD is a square. AF equals 5 centimeters. FB is perpendicular to BE, and it asks for the x. So first, this angle is A, and this angle is B. So this angle automatically becomes A because they are B and A is equal to 90, and one angle of a square is 90. So this angle becomes B2 because question gives us this angle over here is 90 degrees. So this is B. B sees 5 in this triangle, and so the x will be 5 too. And you might ask this why, because 90 A and B, there's similarity in these triangles, so x equals 5. This is a simple similarity question about rectangles. The question states that ABCD rectangle is similar with LEFK rectangle. So we need to make a simple equation for these questions. AB, the longer side of this rectangle, divided by the longer side of this rectangle, is equal to the shortest side of this rectangle, which is CB, divided by the shortest side of this triangle, which is EF. So AB is 9, LE is 6, CB is 6, and EF is X. So 36 equals 9x. From this equation, x comes out to be 4. So we call it 4. Here I have a question about the sinus theorem and parallelogram. So in this question, the question asks for the area of the parallelogram, and it gives this diagonal as 6, and this diagonal as 4. This angle is 12, and this angle is 18. So this angle becomes 150. So this is 360 all, and this becomes 30. So let's remember the sinus theorem. The length of this side, this diagonal, or let's call it x. The length of this diagonal, times the length of this diagonal divided by half, and times the sinus of this angle. So x is 6, y is 4, and sin 30 is 1.5. So this is all adds up to 6. The correct answer of this question is D. In this picture, ABCD is a parallelogram, and AE and DE respectively are the angle bisectors of A and D. The length between the side DC and the point E is 4 centimeters. The length of the side AB is 12 centimeters, and the questions asks the area of the parallelogram. So first, and this is angle bisector, this is angle bisector. So we can say that this is a right angle, and because of the magnificent tree rule, this is 4 centimeter too, and again because of the magnificent tree rule, this becomes 4 centimeter too. So we have the height of the parallelogram 8 centimeters, and we have the base of the parallelogram 12 centimeters. So to find the area of the parallelogram, we just multiply these two, and this gives us 96. So the answer of this question is A. In the picture below, ABCD is a parallelogram. Angle DAB is 60, angle EDC is 30, and angle CDE is 20. The question asks for this angle. So we know that this angle at this angle are equal from the parallelogram and from the properties of parallelogram, and this is all 360. So 360 minus 60 equals 300. So this is 300 here. We know that all of the quadrilateral's interior angles add up to 360. So 360 is equal to 30 plus 20 plus 300 plus the angle here, which is x. So x comes out to be 10. And the correct answer of this question is A.
This is a really good question I found on the worksheets that the teachers gave us. It is very good because it includes two properties about quadrilaterals and polygons. So the question that asks for this length AP, and the question give us this length DB as 8 and this length PB as 2. So let's start. To find we need to find this length in order to find this length too. So we have a theorem. So if we call this P and if we call this R, P times R is equal to, if we call this H, H square. So P is 8, R is 2, this makes 16, and 16 is square root is 4, which is H. So this side is 4. And we have another property too. The length of this side, 8 square, plus the length of this side square, 2 square, is equal to the length of this side square, which is 4 square, and the length of this side square, which is x square. So 64 plus 4 is equal to 16 plus x square. 68 is equal to 16 plus x square. 52 is equal to x square, and x is equal to 2 root 30. This is a nice question about the rhombus. So ABCD is a rhombus, AE and BE are 13 and EC is 3. The question asks for the area of this rhombus. So let's first draw a diagonal here. So as you all know, diagonals divide the rhombus into divide the other diagonal into two equal parts. So we know that this diagonal is 16, sorry. So this side becomes 8, and this becomes 5, because 5 plus 3 is 8. So from the Pythagoras theorem, this side turns out to be 12. And we know that diagonals divide into two equal parts, so this is 12 too. To find the area of the rhombus, you just multiply the two diagonals and divide it by 2. So D times CA times 1/2 is equal to the area. So BD is 24, CA is 16, is equal to 384 divided by 2, which is 192. Area of this rhombus is 192.
Hello, it's Canberk. Now I will show you the solvings of some questions about triangles. Let's look at this question. In this question it asks us the angle E. We find the angle E's answer in terms of x and y because of the properties of triangles, which says us it equals to 2x plus 2y. Before we reach the answer, we need to find the sum of interior angles of triangles, which is 3x plus 3y equals to 180. So now we need to find x plus y. We find it by dividing 180 to 3, which is 60. Now the answer of angle E in terms of x and y is 2x plus 2y. So we multiply 60 by 2. So 2x plus 2y and the angle E equals to 120, which is the C section. So our answer is 120. Now I will solve the second question for you. In the question it asks us the sum of x plus y plus z plus t. Because of the rule, sum of two interior angle, which is y and x, gives us the third one's exterior angle, which is here. So here is x plus y. We apply the same rule here. The sum of z plus t is also the sum of this angle. Now we need to find this angle's exterior, so we can subtract it from 360. We find it by subtracting 35 from 180, which is 145. So now 145 plus x plus y plus z plus t equals to 360. This is because of the rule again. Now we subtract 145 from 360, which is 215. 15. Now 215 equals to x plus y plus z plus t, and this is the answer. Let's look at the third question. In the question it asks us the angle EA. Since it says in the question that these two sides are equal, this angle is also 50 degrees. Because of the sum of interior angles are 180 rule, we subtract 100 from 180 and we find the third angle of this triangle, which is 80. We again subtract 80 from 180 and we find 100, which is this angle. Now because of the opposite angles, here is also 50, and because of the again isosceles triangle rule, this side is also 52. And now we do the same. We again subtract 100 from 180 and find 80. But we don't actually need to find that. When we look at the bigger triangle, we find that 100 plus 50 plus x plus a equals to 180. So we subtract 150 from 180, which is 30, and the answer is A equals to 30. Our presentation is now over. Me and my friend Yunus learned lots of new things about the topic. I hope you also learned something new about the history, formulas, and properties of quadrilaterals and triangles. People should use these shapes more on the design of buildings and be aware of these shapes in their daily life. If we do research about this topic again, Then we will focus on finding information about more complex polygons and solving more complex questions. Thank you for listening to our presentation.